3D mapping with GIS, creating and visualizing 3D terrain models. Gone are the days when 2D map representation was the norm. The introduction of GIS technology has greatly revolutionized the way we view and interact with maps. The latest trend in GIS technology is 3D mapping. 3D mapping allows for the creation and visualization of 3D terrain models, which is quite popular among GIS professionals and enthusiasts. 3D mapping with GIS involves the creation of maps that display terrain, buildings, and other objects in 3 dimensions. These maps are created using specialized software that allows for the visual eye. Visualization of data on an elevation surface. The data is usually gathered using a variety of tools, which include remote sensing technologies, global positioning systems, GPS, and surveying equipment. One of the most popular methods of creating 3D terrain models is through the use of LiDAR, light detection and ranging, technology. LiDAR technology involves the use of laser pulses to create accurate and detailed 3D terrain models, which can be used for a variety of applications. The laser pulses sent out by the LiDAR instrument bounce off of objects like trees, buildings, and hills before returning to the sensor. The amount of time it takes for the pulse to return to the sensor is used to measure the distance to the object. This data is then used to create a detailed 3D terrain model of T. Key area. 3D terrain models created using GIS technology are useful in a variety of applications. One such application is in urban planning and architecture. Architects can create 3D models of their designs to study their feasibility in real-world settings. These models can be also used to analyze the impact of the design on the environment, including traffic patterns and the effects of the building on the neighboring structures. Another popular application of 3D terrain models is in the field of land management. Land managers can use these models to study the landscape and its various features. They can also use these models to analyze changes in the landscape over time. For example, land managers can use 3D terrain models to study changes in the coastline over time. This information can then be used to create effective land use policies that take into account natural features and changes. 3D terrain models are also useful in the field of disaster management. In the event of a natural disaster like an earthquake or a flood, 3D terrain models can be used to assess the extent of the damage in the areas most affected by the disaster. This information can then be used to coordinate rescue and relief efforts. The creation of 3D terrain models also has great potential in the field of archaeology. Archaeologists can use these models to visualize the terrain and features of a site before excavating. This can help to minimize damage to the site and ensure that important features are not overlooked. Creating 3D terrain models with GIS technology is a process that involves several steps. The first step is to gather data about the area to be mapped. This can be done through surveys, GPS, or remote sensing technologies. Once the data has been collected, it is then processed and analyzed using specialized software. This software allows for the creation of an elevation surface, which is used to create the 3D terrain model. It is important to note that creating 3D terrain models requires significant computing power and specialized software. This can be challenging for beginners and those with limited computing resources. However, there are many companies that offer 3D terrain mapping services to clients who do not have the necessary resources or expertise to create their own models. Apart from the aforementioned applications of 3D terrain mapping, there are many other fields that can benefit from this technology. For example, 3D terrain models can be used to create realistic simulations for military training purposes. Soldiers can train in a virtual environment that matches the terrain of the actual battlefield, allowing them to better prepare for combat. The entertainment industry has also embraced the use of 3D terrain models. Video game designers use these models to create open-world games that feature realistic environments. Additionally, virtual reality (VR) experiences use 3D terrain mapping to create immersive environments for users. The use of 3D terrain models is not limited to Earth either. Recently, NASA has been using this technology to study Mars and other planets. By creating 3D terrain models of these planets, scientists can better understand the surface features and topography. As 3D terrain mapping technology continues to evolve, new applications for this technology will emerge. For example, the rise of autonomous vehicles may lead to the creation of 3D maps of road networks that are used for navigation. This could help to improve the accuracy and safety of self-driving cars. In addition to LiDAR, other technologies such as photogrammetry and satellite imagery can also be used to create 3D terrain models. Photogrammetry involves the use of photographs taken from different angles to create 3D models of objects and terrain. Satellite imagery can be used to create 3D models of large areas, such as entire cities or regions. In recent years, there has been a growing interest in the use of virtual and augmented reality (VR/R) technology in conjunction with 3D terrain mapping. By combining these technologies, users can experience realistic, immersive environments that allow for exploration and analysis of terrain features. For example, VR/R technology can be used to create virtual tours of important sites or natural landmarks. Users can explore these places as if they were actually there, gaining a better understanding of the terrain and its features. Additionally, VR/R can be used in education to teach students about topography, geology, and other related fields. One of the most useful applications of VR/R and 3D terrain mapping is in the field of emergency response. By creating virtual simulations of disaster scenarios, emergency responders can better prepare for real-world events. They can also use these simulations to develop and test new response strategies in a safe environment. While the combination of VR/R and 3D terrain mapping is still relatively new, it has already shown great potential in a variety of fields. As technology continues to improve and become more accessible, we can expect to see even more innovative applications for this technology. Furthermore, the use of 3D terrain mapping is not limited to professionals in the field. Many hobbyists and enthusiasts are also taking advantage of this technology to explore and visualize the world around them. One popular application for hobbyists is in the creation of 3D printed maps. By using 3D terrain mapping software, users can create digital models of their favorite landscapes and then print them in 3D. These models can be used as decorative pieces or as educational tools for teaching children about topography and geography. Another hobbyist application of 3D terrain mapping is in the creation of custom maps for tabletop gaming. Using 3D terrain mapping software, gamers can create detailed maps of their virtual worlds, complete with mountains, rivers, and other features. These maps can then be printed or displayed on a computer screen for use in gaming sessions. As the use of 3D terrain mapping becomes more ubiquitous, new challenges and ethical considerations will arise. One issue that has already been raised is the privacy concerns that arise from the coal. Action and use of data to create 3D models of private property. The use of LiDAR technology, for example, can collect detailed information about the features of a property, including the layout of building and the surrounding landscape. This data could potentially be used for nefarious purposes, such as aiding in criminal activity. Another ethical consideration is the potential for bias in the data used to create 3D terrain models. If the data used to create the models is incomplete or inaccurate, this could lead to bias in the resulting maps and models. This could have serious implications in fields such as urban planning and land management, as decisions made based on these maps could have a negative impact on the common entities affected. Additionally, the use of 3D terrain mapping raises questions about accessibility. As the technology and software required to create 3D models can be costly and complex, it may not be accessible to everyone. This could lead to a divide between those who have access to the technology and those who do not, further exacerbating existing inequalities. Despite these challenges, the potential benefits of 3D terrain mapping cannot be overlooked. Thanks for watching.